Hello, my name is Jinkai Qian. I'm an application engineer at Techkon USA. Today, let's take a look at the Techkon SpectroDens4 spectrophotometers. So let's start from the device hardware first. Each SpectroDens4 comes with cable as well as a charging base. There are two different ways to charge the device. The first option is after you plug in the AC adapter on the side of the base and place your device on top of the base. That will charge the device. A second option is if you plug in the USB cable to a computer, that will also charge the device. When the device is charging, you will see a yellow lightning bolt icon on top of the battery. To calibrate the device, please make sure the absolute white tile on the base is clean. You can use some alcohol and Q-tip. Just gently remove any dust or ink residues. Please do not use something aggressive that might damage the surface of the tile. During calibration, make sure the device is sitting flat on the base and the aperture is pointing right on top of the white tile. To calibrate the device, depends on which function you have selected. The device might ask you to measure the paper white as well as the white tile, or only the white tile is needed. To start the calibration, you will push the down or up the arrow button until the cal icon is selected. Then hit enter. The device screen indicates it's ready for the paper calibration. So I will place the device on a paper white. Push the green button. It will start to read the paper. Next, the device is ready for calibrate on the white tile. Make sure the device sits flat on the base, and then press the green button again. That's it. We now just finished the device daily calibration. On the device itself, we have 4 soft buttons. The up and down arrow button is used to navigate within the device user interface. The arrow pointing left is the enter or confirm. The red radio button is exit or escape. On the side, we have a green button for taking spot reading, or if we hold it, it will start scanning. On the other side of the device body, we have the device aperture. The standard size aperture for the SpectroDens4 is 3 mm. If you are measuring a smaller swatch or samples, you can remove those 2 screws and swap the 3 mm aperture with a 1.5 mm aperture, which is optional for purchase. There are 4 wheels at the bottom of the device, and we will demonstrate how we can use the device to scan later in today's demo. Before we talk about the functions on the SpectroDens, let's look at the user interface on your instrument. The lower left corner always displays the function we have currently selected. If you want to go to use some other functions, you will use the up or down arrow button first to highlight the bottom left corner, then hit the Enter button. That will open up the function list. The bottom right corner displays the current measurement setting for the selected functions on the left. For example, when we measure process ink density, we normally use automatic density function, and the setting we use right now is ISO T with no polarizing filter and absolute SD white reference. To change the setting, go down to the lower right corner, hit the Enter, and you can update the setting accordingly. The automatic density is designed to measure your process ink solids. Make sure your device aperture is aligned with the patch. Pushing the green button will trigger the measurement. If you have multiple measurements, they will be all displayed on the same screen, so you don't have to memorize your previous measured value. The SpectroDens allows users to set up to 5 reference sets, one for each substrate. For example, if I go down to the lower right corner, hit Enter, press Enter again on Density Reference Setup, you will see all 5 reference sets. If I enter any reference set, you will see my current target density for each process inks, as well as the tolerance for each. You can customize those values, depends on your workflow. Once you configured your reference value for each substrate, hit the Escape and go to the triangle icon, which is the Delta mode. Press the Enter. Now it will display the difference between your reference and the measured density value. You want to make sure your density is within the tolerance, and you will get a green check. If the measured value is over the tolerance, you will be getting a red cross. The Density CMYK function allows us to see 5 density values after every readings. For example, if I'm going to measure the process magenta solid here, the main density we should be looking at is 142 under the magenta channel. The top 4 density value, they're ISO density or status density. The 5th one in the bottom is spectral density, and also shows at which wavelengths this color has lowest reflectance, or in other words, highest density. We only use the Dmax density for spectral when we are measuring spot inks. for process inks, we will be utilizing the 4 values on top. You might ask, I just measured a solid magenta. Why I'm still getting value under the cyan, yellow, and the black channel? The reason is there's no ink is spectrally pure. So if I'm measuring magenta, there are still some reflectance outside of the magenta channel that will be displayed under the cyan, yellow, and black. Compared to the automatic density function, the advantage of the density CMYK can be utilized in many ways. For example, if I'm trying to simulate a spot color, in this case 186C, with my CMYK printing press, we can measure our reference color by going to the reference tab on the instrument. Here's the density information for the 186C. Now we can go to the sample tab and measure what we are actually printing on press to simulate this spot color. And go to the triangle to turn on the delta mode. Now the device tells me how I should move my CMYK value in the prepress file to get a much closer match. The dot area function allows us to see to what degree our printed dot is enlarged or the size is decreased. This function needs 2 measurements to be carried out. The first one is the solid patch. Next one will be on the screen or on the tints. For example, I'm measuring the magenta solid and I have a density of 142. Next, I can move on to any screen of that magenta ink to measure the dot area. On this 50% magenta, I'm getting a dot percentage of 64.6%. In other words, I have a dot gain or TVI of 14.6%. If I measure a 75% magenta, I have a dot gain about 12.4%. The dot gain and contrast function is closely related to the dot area function. In this mode, we start with a measurement on a solid patch, and the user can define how many screen patches or tint patches he would like to measure before move on to the next ink. After we measure our solid patch, we will see our solid density. And now you see we have 2 arrows pointing to the next square, which is for our tint patches. This is our dot gain or TVI on a 75% magenta, as well as the print contrast information. Now the arrow is pointing to the 50%. And eventually, we have our 25% magenta. Once we complete the circle, we can move on to other process inks. User can define how many tint patches he would like to measure by going down to the lower right corner, hit enter, enter again on the .gen setup. And here, you can customize the screen values. If you do not want to measure 3 patches, you can simply turning that patch off, and we will be measuring only 2 in this case. If you are printing with extended color gamut ink sets or simply spot inks and care about the docking, you can use the SCTV function, which stands for spot color tone value. Compared to the Mary-Davis equation for process CMYK, that SCTV use tri-stimulus XYZ value that are not based on density information to give us a better correlation between the measured value and our visual perception. When measuring with SCTV, the first patch we capture will be the spot inks solid. Then we move on to any screen or tints of that spot ink to see the dot percentage or dot area value. Since the SCTV is focused on spot color, the ideal measure value should be linear to the input from prepress. In this case, I'm measuring a 50% patch, and the value I wish to see on press is also 50%. The trapping function tells us how well does our process inks cyan, magenta, yellow print on top of each other. Ideally, you want to get a trapping value around 80% or even higher. In this case, we will be getting a decent size of color gamut we can reproduce on the press. To measure trapping, we need to first identify what is our first printed process inks and what is the second. For example, if I want to know the trapping between the cyan and the yellow, which gives me a overprint of green, the first printed ink will be cyan, and that's what we measure first. Next will be the solid yellow patch. Finally, we get to the overprint of yellow on top of cyan, which is the green. And here's our trapping value. After we fingerprint our press, we should record the tone reproduction curve or dot-gain curve for each ink so we can repeat the same quality during production. Once we have those tone value information, we can create our custom TVI curve and load it to the SpectroDens to use during the production. In this table here, you can choose what tint patches we are using, and also what is the corresponding target value with tolerances we want to achieve. You can also load from a file if you already create the template before. So this is one of the curve I built for my cyan ink. I can send this information to my SpectroDens. We can also create a custom reference with user-defined file name. Now let's go to the device and see how we can compare the printed value to the reference. Before I start reading under the printing curve function, I want to go to the lower right corner and then enter the print curve setup. For the tolerance, we have some predefined ISO PSO standard, or you can go to user reference and then choose the one we just built. Hit escape, escape again. Now let's scan our cyan strip. So I have this control strip from solid 90%, 80% with a 10% decrease all the way go down to the paper white. I can just easily align my device aperture, press and hold the green button and slide across the sample. The results screen tells us the green dots represents values within tolerance. If you see red dots, you might have a dot gain that is too high or dot loss that is too low. The printing curve SCTV function is built to measure spot color tone reproduction curve or TVI curve. Normally, the target value for spot ink should be linear. But if you need to create your custom TVI curve table for your spot inks, please refer to the previous chapter, Printing Curve. Please only use the Printing Curve SCTV function for custom-made inks because it's based on tristimulus value instead of traditional Mary-Davis density. The SpectroDens has a printing plate function to measure offset plate. Please note, if you want the most accurate plate measurement, we have a dedicated plate reader called SpectroPlate, which has individual plate profile built onto the device, and that device has a high resolution CMOS sensors. For the SpectroDens, it is using the density information with Mary-Davis and Nelson N factors. So we need to calibrate our device on a particular plate type first. Today I have a Fujifilm offset plate, and this is a linear plate. First thing is we need to calibrate our device on the plate where there's no image lasered. So I will pick a spot on my plate surface, press the Cal button. First, we need to calibrate on the paper white. The paper white here is the plate itself. Then we move on to the white tile on the charging base for absolute white calibration. Now I will read my solid patch on the plate. So this is my density for the solid patch. Next, I move on to the 50% tint and take a reading. On the 50%, I'm getting 54.5. Since I know it's a linear plate, it should be 50%. Go to the bottom right corner, hit enter, and now adjust my Yule-Nielsen coefficient, or the N factor value. By pressing the enter, then we can go lower or higher to the correct setting for this plate type. You will need to do some testing until the measured value match to the linear 50%. So in this case, I know for this plate type, my N factor value should be set to 1.7. Now, if I measure my solid again and measure my 50%, it should be really close to the desired value. And I can move on now to other tint patches. When you measure the highlight area, especially under the 10% tints, please make sure your plate surface has a good uniformity so you will get an accurate reading. Again, if you want precise plate measurement, I recommend the dedicated special plate reader. The Slur and Doubling functions allow us to see if there's any movement between the printing plate surface and the substrate. To measure, we start with the solid patch of that ink. Once we measure the solid patch, we next measure the patch of that ink with the horizontal line. Now we measure that ink with the vertical line. And here's our Slur and Doubling value. If you are seeing a value under 10%, that's probably okay. If the value exceeds 10, then there seems to be a quite serious issue between the printing plate and substrate. We need to adjust. The density graph function can be quite useful when we are trying to capture the spectral density of a spot ink, or understand the ink strength of that ink at certain wavelengths, or other scientific studies. After reading the sample, we have a graph that has the wavelength spectrum on the x-axis. On the y-axis, we have the density range. So this curve is the density curve of the sample across the visible spectrum. The dashed vertical line tells us at that wavelength, we are getting a highest density of this ink at this density value. If you want to know more about density across every 10 nanometers, you can push the enter on the sample tab. Next, display. And here's all the density information. The Expresso Mini function let us to verify the density variation across the sheet or across the ink zones, or even from sheet to sheet. After you take several readings at the different area on the press sheet, you will see the graph has all the density value plotted on the same screen. That helps us to understand how uniform the density across the substrate. We can also use this to check different spots vertically. We can jump to any other colors during the measurement, and the device will start with a new graph. Once we finish the other ink, we can go back to the previous ink at any time, and the graph will be continued. Since the following functions are based on spectrophotometry, let's review what is CIE LAB color space. The L stands for lightness. It goes from 0, which is completely dark, to 100, that is the highest lightness value we can get. The A star goes from negative 128, which is green, to positive 127, which is red. The B star goes from negative 128, which is blue, to positive 127, which is yellow. The CIE LAB plus D function displays not only the LAB but also two density value after each readings. If you are measuring a process ink, please use the density value on top. If it's spot ink, please use the spectral density at the bottom. There are two different ways to create color books and upload onto your SpectroDens. With the free SpectroConnect software, on the right side, you can right mouse click under the color books window and choose New Color Book. You can click on the book name to rename it. Also, once you have the book created, go to the sample color window, right mouse click, and go to New Measurement or Control M. In this window, you can type in the LAB value for that color. Pay attention to the measurement setting when you create those colors. You can also use the SpectroDens under the Reference tab, measure your reference colors. Please be sure, once you're on the Reference tab, hit the Enter, the autosave needs to be enabled. You can enable this option by pressing the Enter key. Now our device is ready to read our reference colors. Once we measured the color, we can rename them. Also, we can select all and drop into the new book which is created. You can keep adding more colors under the same book. Once you've finished, you can drag the book by the name and drop it to the lower left side of the window under the Start button. Now, this book is on the left side. Please be sure to hit the Start button to synchronize with the device. Once the synchronization is finished, we can go to the Reference tab hit enter. Under auto search, we should be able to find that color book. Another way to create color books is by importing CXF3 file. Once we have the CXF file imported, you should be able to see the file name and all the colors under that color book. To upload to the device, drag the book by the name and drop to the lower left window here, and then hit the start button. We'll start synchronization. The best way to get CXF file is by talking to your ink vendor or your customer directly to see if they have any color definition documented in the workflow. The CIE Lab function provides us an easy way to capture the LEB value of your printed sample color. If you like to compare the LEB value of the sample to a reference color, you will need to go to the Reference tab first, hit enter, go to auto search, and select the color book you want to work with. Once you have selected a color book, the delta mode will be turned on automatic for comparison. Based on the measured LEB value, the SpectroDens will automatically pick the closest reference color from the color book, which has the lowest delta E. If your color book has several similar colors and the device picked the wrong reference color, you can simply go to the color book icon, press enter, and choose search for closest color. In this screen, you can reassign the actual reference color we're trying to achieve. And now the delta E will be calculated accordingly. If your workflow requires you to use a different delta E equation, go to the lower right corner, hit enter again on the delta E equation, and you can pick other formulas here. Once you select your delta equation, try not to adjust the settings unless you intend to do so. The CIE Color Circle function is very similar to the CIE Lab function. After you take a reading, not only it shows you the LEB value, but also it will plot the measurement on the A star B star graph, from which you can tell where this color locates in the color space. Another benefit of using the CIE Color Circle function is if you are tuning your ink on the press. After you turn on the delta mode, by comparing to a reference color, the graph tells us which direction we should move the color, we can get a lower delta E. For example, if I'm printing 186C on the press, the current sample is too yellow, and you can see from the delta B star. Also, the lightness is higher than the reference color, or it's not dark enough. From this information, I will try to add some base blue inks, which will not only correct the B star value, also it will make the whole color looks darker. The InkCheck function helps us to determine if the spot ink we are printing on press now has room for improvement in terms of lower delta E. First, I will load the color book I want to use under the Reference tab. Once the color book is loaded, I go to the Sample tab, measure my paper white first. After reading the paper white, now we can move on to the spot inks. For example, I'm printing 186C on the press. Currently, my delta E is 4.6 to the reference at density 1.54. If we increase the density by about 12 points, our delta E can get to 4.2 at density 1.66. If your delta E tolerance for the spot color is 3 or even lower, that means regardless how we adjust the ink film thickness on press, we won't be able to achieve the goal. In other words, we need to stop the press and talk to our ink manufacturer to see if we can get a new formulation. If you'd like to see where those numbers come from, under the Sample tab, hit the Enter, press Next Display. This graph shows us on the x-axis is our density for this ink. On the y-axis is the delta E. So we want to pick the lowest point and draw a line onto the x-axis. Is where is the best density for this ink to give us the lowest delta E. Under the G7 function, first we need to determine which reference print condition we are trying to achieve on the press. By going to the lower right corner, hit Enter and G7 Setup. Under the paper type, you can pick your reference print condition. Next, if you have one of the color strip printed, such as the Techkon gray guide checker, you can select this option under the control strip. Or you can use the single spot mode. Since I have the Techkon gray guide checker printed here, I will be using it for the scanning. First, align your aperture either on the first patch or before the first patch. Press and hold the green button while we go across the color strip. Release the button once we finish the scanning, and we'll be getting an evaluation screen. This screen tells us our solids, overprint, paper white, as well as the gray balance patch. If you get a red cross, that means we need to do some adjustments. For example, my gray balance weighted delta CH for the CMY is too high. Next, I'm going to spot reading my HR 504040 patch. This screen tells me for the HR 504040, I need to drop the magenta and yellow to get a better, more neutral gray balance. You could also spot check your process patch to see if we can adjust the ink keys or the density to get a better delta E. Under G7 function, if you choose to use the single spot mode, you will be asked to measure the paper white first. Once you have read your paper white, now you can move on to any patch you like to measure. Please note, the patch LAB value has to be reasonably close to the reference so the device can recognize and assign the correct patch type to the measurement. If the printed value is far off, then the device might not be able to figure out which patch type should be used based on measurement. The Remission Curve function is designed to display the LAB information with the spectral curve of the sample. If you turn on the delta mode, it will also display the delta L, delta A, delta B, and delta spectral curve. The CIE LCh color space is also quite popular in the graphic arts industry. Especially in Flexo, a lot of people using the LCh value to define their process as well as the spot ink target aim. Just like the L star in CIE LAB color space. The L stands for lightness. It goes from 0 to 100. The C star stands for chroma, and the range goes from 0 to 100 as well. The higher the value, the more saturation or vividness we are getting from the ink. The H star stands for hue angle. The hue angle plays a major role in the LCh color space. A lot of printers, they order inks from the ink vendor by specifying what the hue angle should be, and the tolerance normally is plus or minus 2 degrees. Once the hue angle is accurate, then they will shoot for the highest chroma or the C value they can get from the ink, and eventually the L can be obtained as well. When comparing sample with a reference color under the LCh function, not only we can see the delta E, but also pay attention to the little delta L, delta C, and delta H above. That will tell you if the delta E mostly coming from the hue angle or it comes from the delta L or delta C that we can easily fix by adjusting the ink density. The metamerism is a visual phenomenon when two colors, they look matching under one light source, but they don't under different lightings. So the Metamerism index function here tells us how likely we will see color differences if we switch our light source. Two measurements has to be carried out. The first is go to the reference on your SpectroDens and then measure the reference color. Next, we move on to the sample tab and now measure your printed color or your ink. This screen tells me under different lighting condition, for example, lumen A, C, D50, as well as the F2, F7, and F11. Most be using D50 in the press room, but if the product is for a retail store where the fluorescent lighting is mostly commonly used, then we need to be careful when we see higher values under those three conditions. The pass and fail function allows the user to see if the measured sample LEB value is higher than the custom delta tolerance or lower. By using this function, the user neither need to turn on or off the delta mode, nor he needs to remember what's the tolerance for the delta E. Before using this function, first we need to go to the reference tab, hit the enter, and then pick the color libraries we want to work with first. Next, we can adjust the delta E tolerance value by going down to the lower right corner, hit enter, and then hit enter again before we can adjust the value. Once we pick our tolerance value, hit the escape. Now we can move on to measure the samples. If the measured value is under tolerance, we'll get a pass and green check. If it's over the tolerance, we'll get a fail and red cross. The OBA stands for Optical Brightening Agent. It is a chemical used by paper manufacturer to make the paper looks brighter and whiter. The downside of using OBA from the printer's perspective is under the UV exposure, the chemical OBA will fade away and affecting paper's color. When we check in colors in the press room, all the delta E can be under tolerance. Once the OBA starts to fade after a few weeks or even months, the color or the ink will change color as well. Now it's possible the delta E could fail the tolerance. The OBA-Check function allows us to take a single spot reading and the device will compare the value between the M1 and M2 condition and tell us what is the change in delta B star. You want to aim for the lowest number if possible. If the number is around 5, that means OBA moderate. This is a swatch from the book. The next one is a press sheet from the offset press room. The third one is a digital paper. So please pay attention to the paper you're using in your press room and set your expectation on how likely the color will fade or will change due to OBA. The visual opacity function is designed to measure the opacity value of an ink drawdown on a black and white surface. Today I have a drawdown on a Lanetta contrast card with a black band in the center, and the ink was produced on top of the black and white surface. So first thing to measure is the substrate white. Next, we will measure the ink on the substrate white. Now we move on to the ink on black as the background. And eventually, we need to pick a spot where it's only the black band without any ink. And here's our visual opacity value. If you are measuring a opaque white ink, you should be using the first value. If you're measuring a color ink, please use the second one. The visual opacity function can be really useful if you're printing with metallic substrate with opaque white for the barcode, or in Flexo you print on transparent flexible film. Laying down a good white as the baseline for other inks is very critical.